Hello everyone, my name is premsagar. Today I am going to be teaching you the lesson work and energy of 9th standard. All of you might understand work as doing something. You might go out to play or you might work in your homes. But there is a large amount of difference in these two activities according to science. According to science, work has been done when you apply a force on an object and it moves. Therefore, we can define work as if an object displaces by 1 meter when a newton of 1 newton force is applied on it, then work has been done. This is the scientific definition of force. So while we are studying, we are not doing any work, because even if we are putting on effort and force, we are not moving anywhere. Therefore, work is not being done. However, while playing outside, we move a lot of distances and displacement. We apply force also. This is why work is being done in these activities. And work is also not being done when even if we apply a force and an object does not move. For example, we try to move a heavy boulder or a rock and it does not move. Therefore, work is not being done. And we can also introduce a concept of negative work. It happens when you apply a force but the object moves in the opposite direction. For example, you try to catch a moving bus and it moves along and pulls you, but you are applying force in this direction and the bus is moving in this direction. Therefore, negative work is being done. And the work is also not being done, or the work is zero when the direction of force and the direction of displacement are perpendicular to each other. A best example of this would be a coolie trying to lift a heavy boulder on his head and trying to move along it. So the weight is here on his head and he is moving along a perpendicular distance. But the weight is there itself. It is not moving upside or downwards. Even if he is applying force in this direction, he is moving in this direction. Therefore, the force and the direction of displacement are perpendicular to each other. Therefore, work is not being done. And this was all about work. Next topic comes the energy. We all need energy to do work. Therefore, an object which has energy can always do work. It can be done by transforming its energy into another object. Then the next object gains energy and it has the ability to do work, and thus it displaces. Thus, we have done work on an object. And there are two types of energy. They are kinetic energy and potential energy. Kinetic energy is the energy present in a body by the virtue of its motion. For example, a speeding car, a running boy, a moving cycle, etc. All of these are examples of kinetic energy. We can also define kinetic energy as the work done or the force exerted on a body to make it acquire that velocity. Therefore, it can be written mathematically as half mv square. This can be derived through a long process, but I cannot do it right now. So the formula for calculating the kinetic energy is half mv square. And next comes the potential energy. The potential energy of an object is present due to its virtue of motion. Virtue of position, not motion, virtue of position. For example, a ball at a height. It has a capacity to do work if it is left from there. It falls down and does some work on the ground. Due to this, it has potential energy. And a stretched rubber band is also an example of a potential energy, because its position is elongated, and when you leave it, it suddenly contracts and does some work. This is why it contains potential energy. Now, this was the difference between kinetic energy and potential energy, but we have not yet calculated a formula for finding out potential energy. For this, we can say that work is done when a force is applied and an object moves. So, work is force into S. S is displacement. Therefore, force is Fs, and force is also equal to mg, where m is the mass and g is the acceleration due to gravity, because we know that force is mass into acceleration. So, here the formula would be force into S, or displacement, that is mg into displacement, and displacement is height over here. So, it is mgh. This is the formula for calculating potential energy. All of this was about work and energy, which are very interrelated to each other. Next comes the topic of power. Power is nothing but the rate of doing work. It is measured in terms of watts. It can be defined as 1 joule of work is done over 1 second. Then it is using 1 watt of power. And I have also forgotten to mention that 1 joule is the unit of measuring work or energy. Now let us come to the topic of power. As we know that power is the work done over time, it can be expressed as work upon time, or W by T. The basic unit of measuring power is W or watt, as we know, and a much bigger unit of measuring power is kilowatt. 1 kilowatt is equal to 1000 watts. And even bigger unit of measuring power, for example in daily households as we use, it is measured in terms of units. 1 unit is equal to 1 kilowatt hour. It can be defined as the amount of 1 kilowatt power is used continuously for an hour. That is 1000 watts into 3600 seconds. That is 3.6 into 10 raised to 6 watts or joules. So this was all about work, energy and power. Simple. The topic is what? Thank you.